Good evening, ladies and gentlemen. Thank you for giving me a screen and voice. I will talk today about the composition of lignin. Today, basing on photocatalytical, based on Professor Fang Liu from Dalian University. Heterogeneous catalysis as a tool for production of aromatic compounds from lignin, a work written by Professor Nathalie Tanchou from Montpellier, Institute of Charles Gerard in France. And last is valorization of homogeneous linear catechal lignin opportunities and challenges by Arthur Ragauskas from Tennessee University. The work is using different attempts to solve lignin. One is so lignin important because it's very difficult and blocking of production of biofuels in from when we decomposing of cellulose waste. The is the biggest trouble because cellulose we can get ethanol, levulinic acid, and formic acid, while from hemicellulose we get also valuable chemical intermediates. The lignin is big trouble. Its wall functions as a matrix between cellular fibers and give mechanical strength of the plant. Therefore, it can be made from synapple alcohol, coniferol, and procamerol in case of softwood. In case of hardwood, in case of softwood, we have more buyanol alcohol and with coniferol alcohol, and this is trouble. The lignin derivatives comes as good epoxy glues for wood and packages and filler for bitumen and oil drilling fluids. But how we can process this plant? We have several types. The Professor Ragauskas made research of vanilla acid mostly, while Professor Nathalie Tanchou make on repolymerization and comparison of different methods to bring the general review. The Professor Ragauskas makes by organosolv methods, so simply organic chemistry. Professor Fang Li prepare organic catalytic by using special organic nickel aluminum solving to helps to improve this organosolv like method which used for vanilla acid, but Professor Fang Yu used a beech wood as main subject of the research, because in China, the beechwood is the highly important tree wood for furniture from Europe, especially from Poland. And this beech southwest, in case of China, is huge problem because they need to utilize. They try, in case of try, to use nickel catalyst and some enzymes uh, from from industry cellulose and using nickel catalyst with mixed water solution with uh, with tetramethyl benzene as as organosoft solution, while in case of of, of Professor Ragauskas, he used for the run nickel desulfurization, so so nickel and alkaline nitro base benzene. These are two solutions. In case of Professor Natasha, she compares different strategies by base catalyst, acid catalyst depolarization generally, oxidative lignin depolarization, and pyrolysis. In case of Tanshu, they compare the method and that acid pretreatment has low product purity, and advantage is quite fast removal of saccharides from cellulose, while Clason method, so sulfuric acid using, has also has easy preparation, easy broken, but also low purity. The alkali treatment is that condensation is irreversible and many part reaction can occur. And softwoods are much more easily degradable by alkali method. In case of wood, we can use by brown rod. We can use, but it's slow and can eat and depolymerize. But the rate of using is very slow in compared to us chemical. Professor Nagauskas from special reactor and treated seeds gives in 230 solution. And after nickel catalyst, it breaks into depolymerization get lignin. This depolarized lignin goes to obtain such compounds like muconic acids and aniline, and this from catechol. And this obtains some plastics from lignin that could be used in prosthetics for replacing of the collagen in our bones synapses on and cyst, so we can use as synovial replacement. So this is quite big usage that can be used, and synthesis can give us help to obtain the gene regulation by this method of Ragauskas fine chemicals and solvents. In case of using acids, not we kept very impure, so we cannot use this. And according to why, in case of beach using and Arkansas, the nickel base is not so pure to use in pharmacy, but can be used as addition to oils. In case of cat, lignin monomers get in the right conditions. The monomers depolarize, but still dissolved as it cannot be. It can be used only on uh, removing on some biofuels. So Ragaska's method is finer because more pure and more faster than using rods of Professor Simons. And lignin acid polymerization is, according to Natalie Channel, oldest method because from 1920, but still very blocked because corrosive material gases and this is the cost. This cost of equipment are biggest trouble and no such purity. So it can be used in some for the polymerization, but cannot use in for use pharmacy. And catechol and phenol can be obtained. So it is a green method to use phenol. In case of oxidative, when use, for example, hydroxide, the main product can be used lignin percentage as vanillin and can be used uh, in vanillin, and Monsanto uses as production of herbicides and cobalt oxides. And the next problem is that unpure, but this method is Monsanto, as we know, don't work very well. Are not safe to environment. In catalytic pyrolysis, the catalysts break and mechanocatalysts, so catalysts which are working due to friction and breaking this lignin are quite important because they can be such pure like chemicals. But Professor Shatner should like the formation of tar and to pyrolysis. And then we can use the solvents and literature of catalyst is that it depends of what we want. If you want to use more phenolic compounds, then nickel a catalyst. As we saw, alkaline and nickel give good properties for use, good for beach and for using to pharma for to use in fuels. In case of nickel catalyst and methyl and um, acid bromide and nitrobenzene. This can be used for polymerization and using in pharmacy for placing in synovia. In case of platinum and silicon, used to cresols. In case of ruthenium particles, but all are very expensive. This is quite expensive. This is the trouble. So and That work is to not toxic and work, especially in case of pyrolysis, how to make it uh, without destroying the catalyst. So this is the case what I wanted to say. Thank you very much for listening to me, and I hope to start. Thank you very much.